Hey, 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 how's it going, everybody? Welcome to the stream today. Today we are going to be doing some TryHackMe. Oh, there's my big old face on the screen. I don't want to see that. Okay. So, welcome to the stream today. I want to thank everybody for being here. The stream is sponsored by Secure Point Solutions. I want to thank them for their sponsorship. And tell you a little bit about them. Secure Point Solutions. Embark on a journey of cyber resilience with Secure Point Solutions, your trusted partner in safeguarding against evolving cyber threats. They are committed to excellence, and they seamlessly integrate leading cybersecurity practices to shield their clients from vulnerabilities. Some of their offerings do include specialized training, security assessments, tabletop exercises, virtual CISOs, virtual CISO, cyber defense solutions, offensive security solutions, vulnerability management. Check out Secure Point Solutions, and you too can get cyber secure. You can check them out by going to their website, and let's see, secureps.net, right there. Bam. Check them out. Tell James I said hi. Tell him I sent you over. Super nice guy. He's going to get you set up. He's going to get you secure and get you help. So make sure you give them a call. And I want to thank, again, Secure Point Solutions. Now, onto the hacking, which I totally just realized I didn't have that up. So there's their website, Secure Point Solutions. So make sure you head over there. Check them out. They have a LinkedIn. They have and Instagram, they have Twitter. I'm pretty sure they have Instagram. I'd have to recheck that one. But they do have Facebook, so check them out. If you don't need it, maybe somebody you know does. Small businesses, medium, large, give them a call. They'd be happy to pick up the phone and help you out. So, now, let's head over to TryHackMe in the advent of cyber. So, today, let's see what we got going on here. Today we got day 6, Memories of Christmas Past. And once again, if you can't hear me or if the music is too loud, let me know and I will get that fixed up for the stream. So, throughout the merger, gotta start the machine. Always gotta start that machine. Throughout the merger, we have detected some worrying coding practices from the South Pole elves. To ensure their code is up to our standards, some frostlings from the South Pole will undergo a quick training session about memory corruption vulnerabilities. All courtesies of the B team. Welcome to the training. Hey, we're going through the training. Woo! Today we're going to understand specific languages may not handle memory safely. Understand how variables might overflow into adjacent memory or corrupt it. Exploit a simple buffer overflow to directly change memory you are not supposed to access. Before moving forward, we got our machine started up as per usual, and we will have a VM today, which is what we got going on here. Not split screen, and there is a direct link available. So once it becomes available, after we hit the machine, all you need is for this challenge is available in the deployable machine. Once the machine has started, you can access the game. If you receive 502, please give the machine a couple more minutes to boot and then refresh the page. So we'll give that a moment to boot. While that does, let's scroll down a little bit here. The game. In this game, you will play as cat or mouse. Your objective is to save Christmas by buying the star for your Christmas tree from Van Frosty. In addition to the star, you can buy as many ornaments as you can carry to decorate your tree. To gain money to buy things, you can use the computer to do online freelance programming jobs. You can also speak to Van Holly to change your name for a fee of 1 coin per character. He says this is totally not a scam. Sounds about right. He will actually start calling you by your new name. He is, after all, into identity management. So let's open this up a while and see Okay, we got the game loaded up. So before the training starts, Van Jolly approaches Mick Honeybell and says that they'll be observing some weird behavior, or they've been observing some weird behaviors while playing the game. They think the ghost of Christmas past is haunting it. Woo! Mick Honeybell asks them to reproduce what they saw. Van Jolly boots up the game and does the following, which you are free to replicate too. Use the computer until you get 13 coins. Ask Van Holly to change your name to Scrooge Rocks! Suddenly you have 33 coins out of nowhere. So, let's go here. Hit that. So there we go. Speak tab. Backspace, reset inventory. Okay. To finish the game, all you need to do is get a star to put upon your Christmas tree. After you get the star, just interact with the Christmas tree, and that's it. You are free to buy as many additional ornaments as you can carry to customize your tree. So, space, Van Holly. Howdy, cat or mouse. I can change your name for 1 coin per character. Sounds like fun. Let's do it. And so let's see what that name was. And what I'm going to do here is I'm going to switch to the full screen. I'm going to make that a little bit smaller. Move this over here. There and there. There we go. And then we can see both. Okay, so we're over here. So we want to change it to Scrooge Rocks. If it's interesting. Please input a name. Oh, use the computer. Okay. Return. Okay. That's what I did. Enjoy your new name. I didn't do a new name. Thanks. Do you even change names anymore? I work in identity management, you know. Okay, good. I'm glad you didn't take it. First, let's go talk this. Welcome to the store. Is there anything you want to buy? Nope. Not yet. McSkitty's in the game? What? So, let's see. Is that it? Space, space. You just keep doing it. Okay, so you keep pushing space till you get 13 coins. And then you go change your name. So, I see. Each coin, each letter costs a coin. So, I got 13 coins now. Go over here. Space, space. Scrooge Rocks. Hey, enjoy your new name. And I got 33 coins. Okay. Explains that when you change your name to anything large enough, the game goes nuts. Sometimes you'll get random items in your inventory, or just coins, or your coins just disappear. Even the dialogue can stop working and show random gibberish. This must surely be the work of magic. McHoneybell doesn't look convinced. After some thinking, she seems to know what this is all about. Memory corruption. Remember that whenever we execute a program, this game included, all data will be processed somehow through the computer's RAM, or random access memory. In this video game, your coin count, inventory position, movement speed, and direction all are stored somewhere in memory and updated as needed as the game goes on. Usually, each variable stored in memory can only be manipulated in specific ways as the developers intended. For example, you should only be able to modify your coins by working on the PC or by spending money either way, or either in the store or by changing your name. In a well-programmed game, you shouldn't be able to influence your coins in any other way. What happens if we can indirectly change the contents of the memory space that holds the coin count? What if the game had a flaw that allows you to overwrite pieces of memory you're not supposed to? Memory corruption. Memory corruption vulnerabilities will allow you to do that and much more. Honeybell says a debugger will be needed to check the memory contents while the game runs. On hearing that, Van Sparkles says that they programmed a debug panel into the game that does exactly that. This will make it easy for use. So, let's see here. Over here, there's our debug menu. And wow, they did make it easy. So there's the the player name, which stores it in there. There's our exclamation point, so we like overflowed into this, and it gave us even more coins. Shop, keep names, Van Frosty. Namer name, Van Holly. Inventory item. Okay. So ASCII view, the memory contents will be shown in ASCII encoding. It's useful when trying to read data stored as strings. Hex view, the memory contents. So if I do tab again, that's the hex view. Okay, that's it. That's neat. So the memory contents will be shown in hex. This is useful for cases where the data you are trying to monitor is a raw number or other data that cannot be represented as ASCII string. Viewing the contents in memory will prove helpful for understanding how memory corruption occurs. So be sure to check the debug panel for each action you make in the game. Remember, you can always hide the debug panel by pressing tab until it closes. Investigating the Scrooge Rocks case. Armed with the debugging panel, McHoneybell starts the lesson. As the first step, she asks you to restart your game. Refreshing the website should work. So refresh the website and open the debug interface in the hex panel. There we go. Okay. The Frostlings had labeled each of the stored variables in memory, making it easy to trace them. McHoneybell wants you to focus your attention on the coins variable. Go to the computer and generate a coin. As expected, you should see the coin counter increase in the user interface and the debug panel simultaneously. We now know where the coin count is stored. So let's go through here. Oh, there we go. So our coin, you can see right here, it's going up by 1 each time I click on that. So we're at 6, 7. Okay. Go to the computer. McHoneybell then points out that right before the coin memory space, we have the player name variable. She also notes that the player name variable only has room to accommodate for 12 bytes of information. But why does this matter at all? After a confusing Van Twinkle, but why does this matter at all? Asked the confused Van Twinkle. I hope you enjoy the voices. Because if you try to change the name to Scrooge Rocks, you would be using 13 characters, which amounts to 13 bytes. Oh, I'm sorry, I didn't do a voice for that. Because you try to change your name to Scrooge Rocks, you would be using 13 characters, which amounts to 13 bytes, replies McHoneybell. Van Twinkle, still perplexed, interrupts. So, what would happen with that extra byte at the end? McHoneybell says, it will overflow to the first byte of the coins variable. To prove this point, McHoneybell proposes replicating the same experiment, but this time we will get 13 coins and change our names to A, B, B, C, 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 X. Meanwhile, we'll keep our eyes on the debug panel. Let's try this in game and see what happens. So, keep going until I get to 13. Get those coding jobs. Do. Look at that. So, instead of it jumping up to 11, it's 0B. So that's hex for 11. 0C. 0D. So now we go up here. We're going to change our name. And as we do, so A, B, 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 C, 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 X. And then we hit return. Oh, look at that. We got 120 coins now. Because 120 in hex is 7, 8. So, let's point. All of a sudden, we have 120 coins. The memory space of the coins variable now holds 78. 13, boop, and then you can see here. Remember that 0x78 is hexadecimal equals 120. So by putting that X there. That's interesting. Okay, to make this even clearer, let's switch the debug panel to ASCII. So over here, there's the X. So we filled those up and put that there. So the X at the end of our name split over into coin variables. The ASCII hexadecimal value for X is 0x78. So the coin value was changed to 0x78, or 120 in decimal representation. So, as you can see, McHoneybell's predictions were correct. The game doesn't check if the player name variable has enough space to store the new name. Instead, it keeps writing to adjacent memory, overwhelming the values of our variables. This vulnerability is known as a buffer overflow and can be used to corrupt memory right next to the vulnerable variable. Buffer overflows occur in some programming languages, mostly C and C++, where the variable boundaries aren't strict. If programmers don't check the boundaries themselves, it's possible to abuse a variable to read or write memory beyond the space intentionally reserved for it. Our game is written in C++. Strings in more detail. By now, the Frostlings look baffled. It never occurred to them that they should check the size of a variable before writing to it. Van Twinkle has another question. When the game started, the main character's name was Cat or Mouse, which only uses 10 characters. How does the game know the length of a string if no boundary checks are performed on the variable? To explain, McHoneybell asks us to do the following. Restart the game, get at least 3 coins, and change the name to Elf. So, come on, restart, space, 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 2, 3, 4. Okay, we're at 4. Okay, Elf. Enjoy. So, as we can see, Elf or Mouse. So, it looks like it zeroes out the next digit, but leaves the rest of it, so that it's still stored in memory. So, as a result, your memory layout should look like this. And it does. When strings are written to memory, each character is written in order, taking 1 byte each. A null character represented in our game by a red 0. It is also concatenated at the end of the string. A null character is simply a byte with the value 0x00, which can be seen by changing the debug panel to hex. So if we can see the 00. While reading a variable as a string, the game will stop at the first null character it finds. This allows programmers to store smaller strings into variables with larger capacities. Any character appearing after the null byte is ignored, even if it has a value. To better explain this, Honeybell proposes a second experiment on the string. Get 16 coins. Rename yourself. Okay. Are we starting this over? I don't think so. Let's just do this. Spam that. Spam that button. We're at 5. Make my cat go. 8, 9, 10. Oh, neat. I don't need to spam the button. I just need to hold it in. Ha! That's good to know. But I need 16. Oh, my PC's broken. Uh-oh. Okay, space. Space. Okay, so we're doing A, B, 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 C, 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 D, 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 D. Oh! Well, would you look at that? You can even see that it overflows into here. There's not enough room on there. And if you look at that, holy Toledo, look at all our coinage now. Notice how the game adds null characters after 16 bytes, which overwrites the shopkeep's name. Yes, it does. So, if we go down here, yeah. Thanks. Let's just go down here, the shopkeep's name. Oh, look at that. So now it sees the null byte and doesn't read anything after it, so the shopkeep's name is empty. Notice how the game adds a null character after 16 bytes, which overwrites the shopkeep's name variable. And so, let's see here. If you ask the shopkeep, you should see his name is empty. Yep. This happens because the game reads that from the start of the variable up to the first null byte, which appears in the first byte in our example. Therefore, this is equivalent to having an empty string. On the other hand, if you talk to Van Holly, you should see your own name be, which is 16 characters long, which we did. Since C++ doesn't check variable boundaries, it reads your name from the start of the player names variable to first null byte it finds. That's why your name is now 16 characters long, even though the player name variable should only fit 12 bytes. Part of your name now overlaps with the coins variable. So if you spend some money in the shop, your visible name will also change. Buy some items and see what happens. Well, let's go buy some items. Van Twinkle mistyped the name during the previous experiment and ended up with ending with G. So let's go here. Let's get that. So we got enough for the stars. So D. Enter. Hey, you're not supposed to have that kind of money. I earned each coin fair and square-ish. Now give me that star. The game is supposed to be unwinnable, you know. Here, I'll cut you a deal. I'll give you a much cooler item for the same price. That's not what I wanted. So it looks like we gotta do some interesting things. So, let's go. Out of curiosity, they used the online tool to convert the hexadecimal. So, let's see. Okay, so we're going to return. Go up here. Oh, look at that. Because we spent some money. So we're going to go with our name. A, B, 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 C, 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 D, E, F, G. There you go. Entered your name. Is there anything else? Work in identity management, you know. So, using the tool that converts hexadecimal to decimal numbers to check if the hexadecimal number from the debug panel matches the coin count. So, I have the same thing. So, let's see here. The hexadecimal for, there we go, is 44454647. So, CyberChef to the rescue. 44454647. So DEFG, so that's correct. What was it? And so we're gonna do decimal numbers. So get out of here. So it'll be 0x 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 0x. No. Oh, okay. So, oh, yeah, that's right. No. Does it still do the same thing? It does, still does the same thing. We want it to be none. Okay. Oh, okay. So we want it from hex to decimal. Decimal to decimal. Whoa, 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 whoa. Get out of here. Get out of here. So... Nope, that's not what I wanted. Get out of here. Okay. Well, let's just use their online tool because I'm evidently striking out here. So, online tool. So let's do hex to decimal. 44, 45, 46, 47. Convert. And did I do that properly? 44, 45, 46, 47. So 114. So I have this number, but okay. Let's see. They're surprised the numbers were different. Yeah. McHoneybell explains that integers in C++ are stored in a particular way in memory. First, integers have a fixed memory space of 4 bytes, as seen in the debug panel. And secondly, an integer's bytes are stored in reverse order in most desktop machines. This is known as the little endian byte order. So let's use an example to understand this better. If you take your current coin count of that and convert that number to hex, you'll obtain corresponding to what's shown by the debug panel, but backwards. How many coins would you have if the hex value of coins variable was shown in memory as follows? Input your answer at the end of this task. So if you have it backwards, so it'd be 47, 46, 45, 44. Convert. Hey, look at that. We got it. And so, winning the game. McHoneybell is able to wrap up the lesson and call it a day, but first she explains how the attacker could now overwrite any value to the coin variable and have enough to buy the star and finish the game. On hearing this, McGreedy starts laughing manically and tells McHoneybell they rigged the game so nobody could win. McHoneybell is more than welcome to try to purchase a star, McGreedy says. Confused, McHoneybell does some quick calculations and concludes she should be able to get enough coins. She looks at you and asks you to show how the vulnerability can be exploited. You notice that she looks a little doubtful, but still, it's now up to you to win the game. Can you get the star in the inventory and prove McGreedy wrong? So, once you get the star, interact with the tree to finish the game. Okay, so, if the coin variable had the in-memory value in the image below, how many coins would you have in the game? So, So if it goes backwards, 53, 50, 4F, 4F. So it should be 53, 50, 4F, 4F. So it should be that. If I did it correctly. Woo! I did it correctly. Yay! So, let's see. Now we gotta win this game. We gots to win this game. If the coin variable had the in-memory value, okay, so let's go over here. So let's buy 1. So shopkeep's name. I want to look at this. So 31. Okay. Thanks for the purchase. 2. 32. And think I'm seeing a pattern here. So let's get rid of that and do 3. 3. 3. Oops. Which gives 33. So Can I put more than one? Oh, no, you can't. So D, it should be 30. So what if I do 7? Probably restocking Christmas 2024. And if I do D, not supposed to have that kind of money. Supposed to be unwinnable. Something much cooler. So it looks like. What if I? So what's those? I wonder if I could. Because it looks like. I'm wondering if I could keep naming my character. Oh, okay, that's how I do it. So, okay, I think I got it. So if I look here, and I go by what the stock is, so this is 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. Yeah. If I got that correct, I wonder if I can get... Let's purchase McSkitty for funsies. So we got McSkitty. So if we go up here, and we're just going to do space, space, and we're just going to spam this with D's. Oh, now I'm crashing things. Look at my inventory. Ah. D. Okay, so... Oh, and I broke it. Yeah, I broke everything. Okay, so what we're going to do is we're going to restart the game. Debug panel. So I want to get it to where... So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 44. So 44... Okay, so let's just go. Get ourselves a bunch of coins. Oh yeah, I forgot. I don't have to like keep tapping it. That's my bad. So let's see here. Oh, PC broken. Oh boy. Actually, what's in here? Nothing? Okay. Okay, so let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, it's 16, so yeah, okay. There we go. Thank you. Now that I got all those coins. 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. So, yeah. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's 44. So the next one should end up being... So let's just do... what was it? 39... I don't know. 40. So let's do 1, 2, 3. And let's give that a try. Let's see what happens. Look at that. Our last null bite. Look at how many stars I got. Yeah, just flood it with D's. Thanks. Oh, look at that. Bam. Woo! We won the game. Whambo Blambo. Ah, is that Frosto? You got the star. Thanks for getting me ready for Christmas. Here's your flag. Woo! We got the star. So we needed to put in just the right amount so that it would end up putting that into our inventory. So let's see, THM, because I don't think I can copy that. Mick Honeybell is the star. Yeah, Mick Honeybell is the real star. Bam. Sweet. Okay, we got that one done. And just like that, let's move on to the next. So let's terminate. And we're going to move down to 7. Why do I do that? Bam. Now scroll up. Bum, bum, bum. There we go. We're going to X out of that. Make that widescreen and just go with that. There we go. Scroll down, scroll down, scroll down. So let's read the story. I'm pretty sure I clicked start machine. That's interesting. So let's just give this a quick refresh. Okay, so to take revenge for the company demoting him to the regional manager during the acquisition, Tracy McGreedy installed the Cryptoid Miner, a malware he downloaded from the dark web on all workstations and servers. Even more worrying and unknown to McGreedy, this malware included a data stealing functionality, which the malware author benefits from. So, the malware has been executed, and now a lot of unusual traffic is being generated. What's more, a large bandwidth of data is seen to be leaving the network. Forensic McBlue assembles the team to analyze the proxy logs and understand the suspicious network activity. In this objective, we are going to learn about revisiting log files and their importance, understanding what a proxy is and breaking down the context of a proxy log, and building Linux command line tools to parse log entries manually. Analyzing a proxy log based on typical use cases. Before analyzing a dataset of proxy logs, let's first revisit what logs are. A log is like a digital trail of what's happening behind the scenes. In a computer or software application, it records important events, actions, errors, or information as they happen. It helps diagnose problems, monitor performance, and record what a program or application is doing. For clarity, let's look at a quick example. Here's our example. There's the IP address, and this looks like the date. Here's the request. It was a GET request to the robots.txt, and it was an HTTP 1.1 version, 200, so it was okay. I believe this was the time to live, TAC, and curl. So, example above, let's see how close I was, is from an Apache web server log. We can interpret it easily by breaking down each value into its corresponding purpose. Source IP, right there, timestamp. The source computer that initiated the HTTP request, timestamp, the date when the event occurred, HTTP request, which was the get.robots. The actual HTTP request made includes the request method, URI path, and HTTP version. Status code 200 response of the web application, and the user agent, which was curl. So they used curl to get the headers, basically. To send the request, I should say. Being able to interpret a log entry allows you to contextualize the events, whether for debugging purposes or hunting potential threat activities. What is a proxy server? Since the data is being analyzed is a proxy log, we must understand a proxy server. A proxy server is the intermediary between your computer or device and the internet. When you request information or access a web page, your device connects to the proxy server instead of connecting directly to the target server. The proxy server then forwards your request to the internet, receives the response, and sends it back to your device. To visualize it, refer to the diagram below. So without a proxy, boom, straight to the internet. Bam, nothing in between, and that means there's nothing in between to come back to you. With proxy server, user access to google.com, that goes to this proxy server right here. And then that proxy server reaches out to the internet, says, hey, where's google.com? And then finds it, gets it, and brings it right back. Just like that. Proxy server offers enhanced visibility into network traffic and user activities. Since it logs all web requests and responses, this enables system administrators and security analysts to monitor which websites users access, when and how much bandwidth is used. It also allows administrators to enforce policies and block specific websites or content categories. Given that our task is hunting suspicious activities on the proxy log, we need to know what possible malicious activity can be seen inside one. Let's elaborate on a few common examples of malicious activities. Download attempt of a malicious binary. Connect to a known malicious binary. Hey, let's go to that website. I'm just kidding. We're not going there. Data exfiltration. High count of outbound bandwidth due to file upload, e.g. outbound connection to OneDrive. Continuous C2 connection. High count of outbound connections to a single domain in a regular interval, e.g. connections every 5 minutes to a single domain. We'll expand further on these concepts in the following task section. So here we go. Start the VM. Is there a split screen? Yep. So we already got that going. Let's keep moving down. We must understand the log contents to work on the data set provided. To make things fun, let's start playing with it by clicking the Start Machine. Already did that. The machine will start in split screen. If the virtual machine is invisible, use the blue Show Split Screen at the top. Already done. The VM contains a proxy log file in the home Ubuntu desktop artifacts directory named Access Logs. So if we right click here and we're going to, if I can see it, open a terminal. There it is. Hey, there's the Nutcracker again. So now that we're here, let's just expand on this, and we are going to make this a tad bigger for you. There we go. So we're gonna cd, so we're already in here. So let's ls. There's access logs. So ls tech la. We have our access log file. It's read write read read. So we can't change anything, but we can. Let's see. Who am I? Oh, we could actually write to it. So we can read and write to it. Can't execute it though. So. And I'm getting that information from this right here. This is for the user that owns it. This is for the group that owns it. And this is for everyone else. So, you can verify this by clicking terminal. Already way ahead of you. You can skip the following section if you're familiar with the following Linux commands: cat, less, head, tail, wc, and l. I'm pretty familiar with these, but we're gonna keep going just so that you can see them as well. Now let's now that we're already in the artifacts directory, let's start learning some Linux commands while playing with the dataset. Cat, or short for concatenation. So if I go cat access.log, bam, it's gonna spit it all out at me. And so it's like just throws all that out at you. So if you have like small files or stuff like that, like it's not bad. Otherwise, you'd want to open it in a text editor or VI or something. So you might be overwhelmed by the contents of the proxy log. This is because the cat command dumps all the contents and only stops once the end of the file has been rendered. But don't worry, we'll learn some more tricks to optimize the output. The less command, because less is more, allows you to view the contents of a file one page at a time compared to cat. So if we do less access logs, bam, and now we can push down. Look at that. and you can use J. Hey, look at that. That looks interesting. So that looks like we got some redirects, OAuth. Okay. So then you can push Q to get out of less. Head will show you the top 10 entries unless you specify it with the TAC N. So if we do head, TAC N, and just do the top one, access.log, boop, the top one. And in opposite, tails, which is what the next thing on here, or tail, and if you use the TAC N as well, will give you the bottom. So that's the last one. But if you do tail, access, it gives you the bottom 10. Cool. WC command stands for word count. And so if you do WC, access, bam. So it command that counts the number of lines, words, and characters in a text file. So lines, words, characters. Try to execute. By default, it prints out the lines, words, and characters as shown in the terminal. For this task, we only need to focus on the line count, so we can use the TAC L. So WC TAC L access.logs, and that will just give us the line count, which is 49,000. Okay, you can probably tell why you got overwhelmed by the cat command. Yeah. NL is the line numbers. The NL command stands for line numbers. It renders the contents of the file in a numbered line format. So then, say we do, like that's saying give that. So what if we do tail, access log, and then we're going to throw a pipe in there and do NL. Bam. It gives us the bottom 10 and then numbers them. Boop, boop, boop. Pipes are fun in this regard. So, let's see. Chopping down the proxy logs. Log McBlue tells us that he has configured the Squid proxy server to use the following log format: timestamp, source IP, domain, port, HTTP method, HTTP URI, status code, response size, user agent. Let's use one of the log entries as an example and compare it to the format above. So timestamp, that's that, and we can see that here. Then we have the IP address. I'm just using this over here. The domain and port, so here's the domain and that the port it's on. Then we have the HTTP method, get, the URI, so slash. So this would basically be in the, if you would see it in the URL bar, you'd see the ocsp.globalsign.com and then slash. That's what that's saying. Status code, so in this case it's 301, so if I remember correctly, that is a redirect. Response code 640, not sure off the top of my head. And then user agent, that's this guy here that runs all the way down to there. So okay, we got all that information. Let's give it a shot. Just making sure I'm not missing any comments from anybody. So the cut command, as you can see in the table above, we can break down the log entry and assign a position in each value so it can be easily interpreted. Now let's continue by using another Linux command line tool to split the log entry per column. It's called cut. Cut command allows you to extract specific sections or columns of lines from a file or input stream by cutting the line into columns based on a delimiter and selecting which columns to display. This can be done using the TAC D option for delimiter and TAC F for position. The example below uses the space as the delimiter and only displays the timestamp column number 1 after cutting the logs. So to do that, cut TAC D for delimiter, space, TAC F1 for the position, so that'd be column 1, and we got to specify what we're cutting it from. So access logs. So now we have all the timestamps. Just like that. Redacted for brevity. I understand that. It's also possible to select multiple columns, just like in the following below, which chooses the timestamps and the domain and port. So column 1 and 3. So column 1, 3, and 6. Bam. Look at that. Lastly, the space delimiter won't work if you plan to get the user agent column, since its value may contain a space, just like the example logs. Given this, you must change the delimiter and select column number 2 because the user agent is enclosed in double quotes. So this one, we would do cut tech D. I see what they did. And then double quotes F2. So in this case, it's saying the delimiter is this, and basically we want everything that's in between those. That's what F2 is, if I'm understanding this correctly. To select column number 2 because it will start there. So in our case, like, let's scroll up. I might not be able to. Yeah, we got too many. We got too many log entries. So, okay. I'm pretty sure it's pretty straightforward. Okay. So as you can see, there we go. It looks like some of them didn't have user agents, or it's just a tag. An example above, we use the column 2 since column 1 will provide the contents before the first use of the double quotes. Try extracting and see how the output differs from the space delimiter. So it's saying to actually do this, and if we do the space delimiter, it's going to give us the second column, which is, if we remember correctly, that would be the source IP. So in this, because we set the delimiter to that is considered like the first column because there was a space here. So yes, yep. I think I'm just overthinking this. Pipes. We get to talk about pipes. So in the previous section, we introduced some Linux commands that will be useful for investigations. To utilize all these commands and produce an output that can provide meaningful information, we can use Linux pipes. In Linux or Unix like operating systems, a pipe, or this character right here, a pipe, is a way to connect 2 or more commands to make them work together seamlessly. It allows you to take the output of one command and use it as input for another command. We'll introduce more commands by going through some of these use cases, almost like what I did earlier. Get the first 5 connections made by the 10.10. Okay, so grep option string to search file name. So if we want to do that, yeah, I was going to say. So we'll do grep, and grep will be searching the string, or the whatever we put in it. It's going to search it for what we are asking for. So grep 10.10.140.96 access logs pipe, and then since we want the, what did that say, the first 5 connections, we were going to use head since that's the top, N5, and that should just give us all of that. But wait, we just wanted the IP address. So before we go further, I want to see if we're going to use top 5. No, we're not going to do that. We're going to do grep for that. We're going to cut tech D space tech F2 and then head. Bam. So that just displays the file, which it's dumb to go as far as I did, but just to pipe commands together. So basically what we did here is we pulled the 5 times that this occurred, and then now we have the domain that it was trying to go to, the method, and all this wonderful information about it. So this was just me messing. I apologize. I have fun. I like the command line. The first command's output may have been a little too overwhelming, which we did not just do grep. We went straight to the second command. Get the list of unique domains accessed by all workstations. To do this, we'll combine the sort and unique commands with cut. Sort is a Linux command used to sort the lines of text files or input streams into ascending or descending order, while unique command allows you to sort or filter out and display unique lines from a sorted file or input. Unique command requires a sorted list to be effective because it only compares the adjacent lines. To achieve our goal, we will start by getting the domain column and removing the port. When we have the list of domains, we'll sort it and get the unique list. So, what are we looking for? Unique domains accessed by all workstations. The first we need to cut, so we're going to cut TAC-D, TAC-F3 for domains and ports. So, and then that's access log, pipe that, and now we're going to, because there is a delimiter of the colon, we're going to cut again TAC-D, but this time the delimiter is the colon, as I just said. Colon TAC-F1, so it's going to be before that colon, before that delimiter. Then we're going to run sort, which will then take all that output, sort it so that it's all together, and then we're going to pipe one more unique. And if you really want to have fun with this, which I always love to do, I do TAC-C, which will also count it, how many times that it occurred. So, bam. And as you can see, now we have the unique URLs, how many times they occurred in there as well. So, frostlings.bigbadstash.thm 1,581 times. So I really like unique TAC-C. I've used it so many times. And so that's what they did. Hey, look at that. The next thing. Let's display the count. They added the TAC-C. I usually do that by default just for funsies. Moreover, the results can be sorted again based on the count of each domain by using the TAC-N option of the sort. So what we end up doing is we run the same command, but we do sort one more time because now we have all these numbers right here that are like in the beginning, and we can now sort TAC-N by that, and it starts at the lowest, but yeah, if we do NR, it'll reverse that order. So at the top, we have the highest count. So office.com. I still love frostlings.bigbadstash. I'm pretty sure that's going to come in handy here. Hunting down malicious traffic. Now that we have developed the skills needed to assist Forensic McBlue, let's get down to business. To start hunting the suspicious traffic, let's try to list the top domains accessed by the users and see if the user accessed any unusual domains. You can do this by reusing the previous command to retrieve the connection count for each domain and the pipe tail.tac-n10. So get the last 10 counts. So they're saying, okay, so get the top list of top domains. So if we do all that, push up again, pipe one more time, tail tack n, which, why would, okay, you don't need the tack n10 because it's going to give you the last 10 anyways. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So tail tack n10, yeah. We use the command since the list is sorted in ascending order, and because the domains with the high connection count are positioned at the end of the list. Oh, I did it the wrong way then. So that would be, I would have used heads. We don't need that, so let's just do that. And tack n10. Oh, crud, no. Darn, darn, darn. Darn, 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 darn. So we want, yeah. That's what we want to do. So we want to take the R off so it's not in reverse order. There we go. We took the R off of the sort, so it sorts it numerically. So it's like that. And then we do tail, so it gives us that. So bam. Checking the list of domains, you'll see that Microsoft owns most of them. Out of the 10 domains, we can see one seems unusual. Let's use that domain with the grep and head commands to retrieve the first 10 connections made to it. So, actually, let's scroll down a little bit here. How many unique IP addresses are connected? Okay, so let's just finish this up. Okay, so we know we're going to grep for frostlings.bigbadstash, if I spell it right, .thm. And what are we looking for? Let's see the domain with the grep and head commands to retrieve the top 10. So then we're going to do head. Dude, what did I do wrong? I didn't do it. Oh, whoa. I see what I did wrong. No. What did I do wrong? There we go. That should give us that once it is done. The first 10 connections made to it. Then why are you searching 5? That's interesting. Frostlings. bigbadstash.thm. I love when I second guess myself. So, well, I mean, it does have to go through quite a bit. So, let's see here. Suspicious. Oh, jeez. That's what I did. It has nothing to grep through. Access.log. Now it's not going to take long. Oh, bam. Look at that. Dunzo. So, it looks like, yeah, they're pulling out stuff and sending it. Interesting. So let's do 10. Yeah. Upon checking the list of requests made to the redacted domain, we see something unusual. The string passed to the goodies parameter. Let's try to retrieve the data by cutting the request URI with equals as the delimiter. So what we're going to do is we're going to do this. We're going to pull that, but we're going to cut tac D with the delimiter of goodies. Oh, wait, no. Oh. So tac 5. So grepping for the suspicious domain, we're going to cut number 5, which should be the URI. Okay. cut F5 cut equals tac 2. So okay, yeah, so we're doing the equals, then 2 would be on this side of it. So what did I do? Oh, F. Oh. See what happens when you're in a rush? Bam! Would you look at that? Based on the format, the data sent seems to be encased in base 64. Using this theory, we can try to decode the string by piping the output to a base 64 command. So, if we do all that, and then pipe one more time, base 64, tac D for decode, well, would you look at that? We got ourselves a bunch of information. And, hey, look, we found a flag. SOC analyst, THM, a gift for you awesome analyst. So, did you notice that the decoded data seems to be sensitive data from Antarctographs? This may be a case for data exfiltration, which now, oh my goodness, this helps me out with something else I'm trying to do. Let's see here. Oh, wait, what's this? Woo! I got some party parrots. I hope they're watching. Hope you're watching, party parrots. So, okay. Holy crap. I don't know what happened there, but there we go. Okay, so now we got this. How many, well, having retrieved the exfiltrated data, what is the hidden flag? I'm just going to go out on a limb and just say it's that. So remember to copy that. It's Control-Shift-C because you're in the Linux terminal there. And Control-V. And there's our flag. Okay, and let's just do that. Ooh, SOC Analyst level 2. I do plan on doing that eventually. I need to finish up with level 1, but I'm also trying to do a write-up for each of those. How many unique IP addresses are connected to the proxy? So, to get that, we're going to unique IP addresses. So, if I remember correctly, that is the second column. So, we are going to cut tac D space F2 access.logs. Then we're going to sort and we are going to unique tac C, and then we're going to well, actually, I guess we don't need the text C. We're going to sort, we're going to unique, and then we're going to word count tac. It was word length character, or word line character, so tac L. So that should be 9. Bam! There we go. Oh, piping's so much fun. How many unique domains were accessed by all the workstations? And that was, actually, let's see what command that was. That was all those, my mistakes. So, if we were doing that, how many unique domains were accessed by all workstations? So, we were looking for, this is pulling the delimiter. The third one would be the domain. Unique, okay, so this would be it. So how many unique domains were accessed? So we actually don't need the sort here, and we don't need the unique tac C. We should just do word count tac L again for 111. Yes, did it again. What status code is generated by the HTTP request to the least accessed domain? So, if we go back up through our lovely commands, So this will sort them numerically. And let's go head. Okay. So what is the status code? What status code is generated by the HTTP request to the least access domain? So that would be partnerservices.getmicrosoftkey.com. So the HTTP status, which line was that? So scroll up. That was the method status code. So 6. So if we do, okay, so we will grep, and we want to grep this. And this time I'm going to remember to write access logs. So now that we've grepped out all those, we want to cut and do the delimiter of space stack space. And to be honest, I don't remember the dummy location. Status code 6. So now we're going to do F6 and let's just give that a shot. So, hey, look at that. If we want to go further, we can do unique 503. Ta-da, 503. Okay. Based on the high count of connection attempts, what is the name of the suspicious domain? And so that would be this right here, frostlings.bigbadstash. Control-Shift-C, Control-V. What is the source IP address? Okay, so on this, we're going to go, because we don't want that, let's just go head. Source IP is this guy right here. And how many requests were made on the malicious domain in total? So, if I remember, that would be, it's like, I forget how many off the top of my head. So that was, I don't know, I just should have to do that. So 1,581. 1,581. So the command we just ran was the cut D, where we're pulling out the domains out of the access logs. And then from here, we are using the delimiter of the colon and doing the space before it, which was the URLs, sorting them, dropping, only showing one count of them, and then counting them as well, and then sorting them numerically by the account number. It's a lot to take in, but it really isn't too bad. The more you work with it, the easier it is, and actually, as I said, so much fun. I love them. I love doing that. So I want to thank you all for hanging out with me today, and as I ran through days 6 and 7 respectively, and now I had a lot of fun with the day 6, the memory corruption, but I actually had a lot more fun just chopping up the log and finding all the goodies in there with day 7. So I want to thank everybody for hanging out with me on the stream today. I plan on being back here around 3 tomorrow for tomorrow's stream of day 8. So I want to thank you all again.